Hey everyone, it's Matt here. Welcome back to another episode of Savant's Tech Talk. Proof of work refers to a system that deems a considerable but manageable amount of work necessary so that thoughtless or harmful utilization of computer resources is discouraged. Harmful utilization includes but isn't limited to spam emails or conducting denial of service attacks. Hal Finney adopted the proof of work concept to secure digital money in 2004. He did this by making use of the SHA-256 hashing method and the notion of reusable proof of work. Having said that, no discussion of proof of work would be complete without mentioning Bitcoin, the cryptocurrency that popularized it. Bitcoin was the world's first cryptocurrency. Its concept was extensively laid out in whitepaper by the pseudonymous Satoshi Nakamoto, whose identity still remains a mystery. It was first introduced in 2009, and since then, thousands of cryptocurrencies have followed suit. Bitcoin was responsible for bringing cryptocurrencies into the mainstream and popularized the distributed ledger technology known as blockchain, which has uses beyond the financial sector. Even retail behemoths like Walmart use blockchain technology to optimize their supply chains. What forms the basis of Bitcoin, along with many other cryptocurrencies functioning, is proof of work, which allows for safe, decentralized consensus. In today's video, we'll look at how proof of work, works in Bitcoin's network. As always, if you find this topic interesting, then don't forget to let us know by hitting that like button and subscribing to this channel for more videos. You can also let us know if you find it interesting by saying so in the comments section down below. Now let's jump into it. So how does proof of work work? As I mentioned, today's video will concentrate on how proof of work works in Bitcoin's network. Bitcoin is fundamentally supported by a blockchain, which is a type of distributed ledger. This ledger keeps track of all of the transactions within Bitcoin and organizes them into blocks, which prevents double spending. In addition to this, the ledger is made public and distributed across nodes to avoid manipulation. A changed or altered version would be immediately invalidated by the other nodes, since it would no longer match their copies of the ledger. To elaborate more, a block is what a node accumulates information into. Each block has a specific amount of storage that will be filled, then closed and added to the blocks that are already full. As a result, those blocks constitute the blockchain, which is a chain of information that every node has a copy of. And recently filled blocks are appended to the chain's end. How nodes notice if tampering is taking place or not is done through hashes. Hashes are strings of numbers and letters that are converted from original data by mathematical functions. In other words, these functions convert the digital information held within blocks into hashes. That is exactly why even a minuscule alteration of original information within blocks will change the hash, making it completely unrecognizable to other nodes. This is attributed to the avalanche effect, which is a major part of proof of work security. The hash created by a particular function will always have the same length regardless of the size of the underlying data set. Therefore, the hash serves as a one-way function where it can only be used to verify whether the data held within blocks is legitimate, and it can't be utilized to get the original data. For a present-day computer, generating hashes for a set of transactions on Bitcoin would be effortless. So the Bitcoin network sets a particular amount of difficulty to transform the process into work. This parameter undergoes alterations that allow for a new block to be mined roughly every 10 minutes. The difficulty is set by deciding on a target or goal for the hash, where the set of acceptable hashes is based on the target. So if the target is low, then that means that the set of valid hashes is also low, which makes it more difficult to construct one. Practically, this implies a hash with a long string of zeros at the beginning. Seeing that the digital information held within blocks only generates a single hash, how are miners able to construct hashes that are below the target? Well, they do that by adding integers called nonces, which effectively changes the inputs. When a valid hash has been determined, it's distributed across the entire network, and then the block is added to the blockchain. Although mining is a competitive industry, it's more like a lottery than a race. Every 10 minutes, someone will produce a valid proof of work, but who that is will be unknown. Miners join forces to maximize their odds of mining blocks, which results in transaction fees and, for a brief period, an enticing award of freshly minted Bitcoin. With proof of work, changing any part of the blockchain is nearly impossible, since all of the following blocks would have to be remined as a result of the manipulation as well. Also, because the equipment and power necessary to execute the hash functions are so costly, it basically makes it impossible for a single user or even a group of users to dominate the network's processing capacity. So there we have it. Blockchains like Bitcoin's network are designed to be decentralized and peer-to-peer, so they need a mechanism to achieve both consensus and security. Proof of work is one of these mechanisms that makes attempting to overrun the network excessively resource intensive. Additional verification procedures such as proof of stake and proof of burn don't consume as much energy, but they do have other downsides to them. The network and the information stored on blockchain would be exposed to assault or theft if there was no proof mechanism in place. Once again, if you found this video interesting, don't forget to let us know by hitting that like button and subscribing to this channel. Thank you for watching.